This meeting is being recorded.
A very good morning, dear friends. Continuing Professor B Viswanathan sir's lecture series on surface analytical techniques. There are a variety of analytical techniques to probe the surface. Characterization of a bulk is different from the characterization of a surface. By surface, we mean top few layers per se. Hundred angstroms means 10 nanometers thick surface. And for that, we need low energy electrons. And today we will see three important surface analytical techniques, namely LEED, low energy electron diffraction, FEM, and FIM, field emission microscopy and field ion microscopy. We are familiar with the field emission scanning electron microscopy. Scanning electron microscopy is yet another surface analytical technique. And these days, SEM with EDAX, energy dispersive X-ray analysis, is widely used to know the surface morphology as well as the surface elemental composition. However, surface analytical techniques like LEED, FIM, FEM, AES, XPS. AES means audio electron spectroscopy. XPS means X-ray photoelectron spectroscopy. These techniques are not very widely studied, not very widely investigated. We do have useful science to learn from these techniques. And this lecture series is named after the well-accomplished teacher, Professor B Viswanathan sir, mainly because the material has been taken from the books authored by Professor B Viswanathan sir. In addition, Professor B Viswanathan sir has been the encyclopedia of knowledge in catalysis science, and because of his hard work, now we have National Center for Catalysis Research, useful for research scholars for conducting their research studies on surface science, especially catalysis. Whenever we talk of catalysis, much of the catalysis happens on the surface as far as solids are concerned. We are talking about solid surfaces. It can be metals, metal oxides. Moving forward, there are three important aspects of the study of the surface. Basically, dear friends, lecturing has widely been misunderstood these days. A better reader is a better speaker. To speak or to deliver lecture better, we need to read. The habit of reading is disappearing these days, and in olden days, the preacher in the church is only allowed to adopt two methods of preaching and teaching. One is to read from the original text, and to teach by his own life example. But for these two methods, the preacher in the Anglican church or the English church is not allowed to preach in any other way. But these days, many transformations have come up, both in the church as well as in the realm of education. Church has much to do with teaching. Basically, Indian education system is a mimic of the English education system. Indians owe much to the Britishers, and during their presence in India, the Britishers did good work related to the spread of education through missionary work and establishment of various healthcare centers and building up of infrastructure ranging from dams for storing water that will facilitate harvesting of food grains and alleviation of poverty. Like that, there are many good things that the Britishers have carried out during their presence in India for over a century. I come from a village, and near that village there is a place called Dhavaleshwaram, and in Dhavaleshwaram there is a dam, there is a barrage, and this dam has been built by none other than the visionary engineer by name Cotton, Sir Arthur Cotton. It is because of his vision that we see today the Dhavaleshwaram Dam, and this has facilitated the cultivation of crops and enhanced the crop yield. And Andhra Pradesh is called the Annapurna, the granary of rice for all of India. Likewise, Punjab. Punjab is the storehouse of wheat. Likewise, Andhra Pradesh is the storehouse of rice. It is because of the efforts of great visionary engineers like Sir Arthur Cotton, who have dedicatedly, selflessly contributed for the welfare of human societies. The Britishers, most of them have never thought that we are serving the Indian community. This should be the attitude. Of course, Indian philosophy is the best of all, and the Indian philosophy is that Vasudhaiva Kutumbam means Vasudha plus Eva means all the earth is one family. So we as Indians never had any distinction that we are Indians and our neighbors are Chinese. We always treated the neighboring nations as as our kith and kin, as our fellow brothers. That is why during the centuries of history of India, India is the only nation that has never invaded on any other neighboring nation, for that matter, even small island nations or even small neighboring nations like Sri Lanka or Pakistan. This is the history of India. Moving forward, where are we? We were talking about the methods of teaching. There are only two methods of teaching. One is reading from the original text. The more we read, the more we speak the original tongue. These days, the habit of reading has almost come to a standstill. We really do not know what to read, which book has to be selected. We are talking about surface analytical techniques, and there are a variety of surface analytical techniques, and among them, of course, spectroscopy stands out. Spectroscopy, among various spectroscopic techniques, XPS, there is no substitute to XPS to characterize the surface of solid materials, to know the chemical composition of the surfaces, to know the elemental composition, to know the valency. What is valency again? Valency is the combining capacity of elements in what oxidation state a particular element is there, per se vanadium, per se lanthanum. Any element, when we talk of perovskites, spinels, any metal oxide, any catalyst material, we can probe the surface of these solids, and we can know the oxidation state of these elements as well as the chemical composition of the solid surfaces using X-ray photoelectron spectroscopy. X-ray photoelectron spectroscopy is also called ESCA. ESCA means ESCA. Electron spectroscopy for chemical analysis. Electron spectroscopy is different. Electronic spectroscopy is different. This is how we need to be careful in distinguishing one technique from the other. Electron spectroscopy deals with using photons as the energy source to probe the surface, and these photons, what the photons will do, these photons will penetrate into the core of the atom, and the electron at the innermost shell, the core electron level, we do have shells, atomic structure. Atomic structure has evolved much, and we do have now a clear picture of atom. Atom, again, what is atom? Dear friends, we all know fundamentals, but the problem is the original tongue is lost. As I say, in good olden days, whether it is the Anglican Church or the English Church, there are only two methods of teaching. The preacher or the father is not allowed to preach in any other way but for reading from the original text. That scenario has changed gradually, and there are various kinds of sermons in the market available these days, and we should be very careful in buying the product, in choosing the product. So even though we do have a shelf full of books, we should be knowing which book has to be taken and which book has to be read. For example, ESCA. For ESCA, we need to essentially refer to the works of Professor Sena Rao sir. Professor Sena Rao sir is an authority on surface analytical techniques, especially ESCA during 70s. Professor Sena Rao sir has written much on this primitive technique, even though it is the oldest possible techniques in the dispensation of solid state chemists. Even though it's a very classical technique, there is no substitute to ESCA as far as the determination of the surface chemical composition or the elemental analysis on the surface is concerned. As XRD, X-ray diffraction is vital for probing the structure of the bulk. Bragg equation, n lambda is equal to 2d sine theta, constructive interference, then Debye equation. These are the fundamental aspects of X-ray diffraction. X-rays are in, and X-rays are diffracted, and the diffracted X-rays are being probed. And the diffracted angle theta carries a wealth of information. That is what we see on the x-axis, 2 theta, and y-axis we see the intensity. And from the 2 theta, from the peak position, we do calculate the d using the Bragg equation. N lambda is equal to 2d sine theta, and lambda is the wavelength of the X-rays that are used to the surface of the bulk material, the solid catalyst. Likewise, as from the 2 theta, we get useful information related to the interplanar spacing, that is t value. And another thing that we can deduce from the X-ray diffraction pattern is the crystallite size. We do have Debye equation, and this Debye equation deals with the determination of crystallite size. Crystallite size, again, this is, as I told you, dear friends, science. Usually, the original text is lost. We use bulk spectroscopic techniques and surface analytical techniques as synonyms. We use crystallite size and particle size as synonyms. But in reality, crystallite size is different from particle size, because, if particle were to be considered as an elephant is comprised of eyes, trunk, uh, and then ivory, teeth, and these are the crystallites in the very large particle of particle. So, particle is comprised of various crystallites, and each of the crystallite is separated by the grain boundary. Each of the crystallites is separated by the grain boundary. From the grain boundary, we can always find the crystallite size using Debye-Scharer equation. Using Debye-Scharer equation, we can get the crystallite size. Likewise, as XRD is a very, very potential technique for the calculation of crystallite size, XPS, ESCA, uh, ESCA, electron spectroscopy for chemical analysis is a very, very promising technique to know the elemental composition. No problem. Sure, no problem. So we can always calculate the binding energy of the electron that is ejected from the core level so that we can get information on the element from which the electron is ejected. Basically, in the X-ray photoelectron spectroscopy, what is being detected is the kinetic energy of the electron that is ejected out from the core level of the atom. Yeah, coming back to atom. As I told you, the original tongue is lost these days, and we do have many sermons in the market, and we should know which sermon has to be bought. We do have many banners like the El Shaddai. These are all what to say. These are all what is called as during what to say bombing. We seek shelter. These are under these names are used by many as shelters, as a cover. So we should be very careful which is the pseudo church, which is the real church. Likewise, as the original tongue is lost these days, we should try to practice the oldest method of teaching, namely reading the original text. As far as possible, I'll try to read the original text, but I will add some interpretation, because interpretation, if you read the book of Pilgrim's Progress by John Bunyan, the whole world is astonished. How come such a layman writes such a literary masterpiece? All the English literature people, pseudo people that are under the banner of, in the disguise of PhD scholars, even though they are not PhD scholars, they say they are PhD scholars. Because, you know, the originality is lost these days. We cannot trust anyone if someone says that I am doing PhD in English. It need not be so. In reality, they are somebody else. If somebody says they are school teacher, we cannot even trust that indeed their profession is a school teacher. These are all various covers in which the thieves may come. In Matthew chapter 24, Jesus Christ warned, many will come in my name. Do not be deceived. So people will come as El Shaddai, people will come as English PhD scholars. Do not be deceived. These are all different disguises. These are all different covers. When we have the Holy Spirit in us, we'll be able to distinguish darkness from light. Okay, going forward, all that glitters is not gold. We have to test if the material is indeed gold. As I told you, dear friends, electron spectroscopy is different from electronic spectroscopy. Okay, electron spectroscopy means XPS, ESCA. In electron spectroscopy, what is happening is photons are used as the field, the source of excitation, the source of probing the material, the source of activation. And when photons are impinged on the surface of the material present in high vacuum, what is happening is the photons are knocking out, ejecting out the electron from the core level. And the core level means K shell, KLM, and we do have different shells. And this K shell electron is usually ejected out, and this ejected out electron will travel with a very, very specific binding energy. You see, my fingerprint is different, and my neighbor's fingerprint is different. No two fingerprints, no two thumb impressions are the same. God has made us so beautifully. Even though Indians are 1.4 billion people, one Aadhaar card is not the same as other Aadhaar card, because each Aadhaar card is based on fingerprints, personal identification marks. God has so beautifully made each one of us distinctly differently, and similar situation is prevailing in the inanimate objects as well. You will be really surprised. Chemistry deals with matter, whether it is animate or inanimate. Chemistry deals with chemical composition. Chemistry deals with characterization. Okay, so we do have more than 120 elements in the periodic table. Each one of the elements can be distinctly, differently distinguished using various probes, using various analytical techniques that are available at the dispensation of chemists. So, going forward, we were talking about ESTA, electron spectroscopy for chemical analysis. This is a very, very promising technique, unavoidable technique, classical technique for the characterization of the surface of solids. As XRD is vital for the determination of the bulk structure, XPS, electron spectroscopy, is vital for the characterization of solids. So in ESCA or XPS, X-ray photoelectron spectroscopy, what is happening when the photons are shown on the solid surface present in vacuum, the photons will knock out the core level electron from the K shell of the element under examination, the compound under examination. It can have one element, it can have two elements, it can have three elements, but say nickel oxide. Nickel oxide will have both nickel and oxygen, two elements. Okay, these two elements are there. And then when the electron is ejected out from the K shell of nickel, it will carry a kinetic energy of specific value. And when the detector detects the kinetic energy, the kinetic energy is a reflection of the binding energy of the electron that is emanating from the core level of the particular element, whether it is nickel, whether it is oxygen. Per se, let us take spinels. Let us take magnesium cobalt oxide. Let us take perovskites. Spinels have the solid state typical composition of AB2O4. AB2O4 spinels. Likewise, perovskites. Perovskites, you should really be careful with these materials, because perovskites are very, very special materials. Even though there are 66 books in the Bible, only the book of Job is referred only once in the whole of the Bible, and James refers to the book of Job, and especially one character of Job is highlighted in the book of James, and that particular character is the patience. Dearly beloved friends, you know the patience of Job. He drank rejection like water. Job was rejected. Job was denied. Job suffered so much without any wrong on his part. Satan has tempted Job very much. All his body was filled with sores. He has no healing in his body. He lost all his wealth. Such a righteous person undergoing so much agony, so much sorrow, so much health complications, so much financial issues. Why? Job said, do we take only good from God? Shall we not take evil? God has given, God has taken. It is because of his patience. It is because of his patience. Because of his patience. It is because of his patience. Job was referred in the book of James, and only once we see the reference to Job in all the 66 books. Nowhere Job was referred except in the book of James in the New Testament, and that too only once, and that too because of his character, that is what is called patience. Dearly beloved, you know the patience of Job. Who is like Job that has drank rejection like water? Yeah, indeed. James is correct. So we often tend to think that, whole day should be very prosperous, should be very fruitful, should be very meaningful. We should not have any disturbance. We should not have any obstruction. But when obstructions comes, what will you do? When hindrances comes, what will you do? नीड का निर्माण फिर नेह का आह्वान फिर नीड का निर्माण फिर नेह का आह्वान फिर. Harivansh Rai Bachchan is a very great poet in Hindi literature, and Harivansh Rai Bachchan writes like this: नीड का निर्माण फिर नेह का आह्वान फिर नीड का आह्वान नीड का निर्माण फिर नेह का आह्वान फिर. Means when in wind, in cyclonic storm, when the nest is shattered, when the nest is damaged, destroyed, will the birds stop rebuilding? No. From nature, from the creation of God, we have much to learn. Need ka ahwan per, neh ka ahwan per. Need means nest, neh means friendship. So, when cyclonic storms come, when destruction struck our way, when there are some obstructions, we should never ever give away. We should never give up. Satan, the enemy of humanity, is roaring like a lion. We think that all is invisible is non-existing, but science doesn't think that. While I was a PhD scholar in the laboratory of Professor B Viswanathan sir, in the seminar room, there used to be a wall photo on the wall, and the frame contains a very old text, original text, and the text reads like this: science is the most difficult, pitiless, yet interesting and very rewarding endeavor that mankind has found in the pursuit of searching truth. I hope I'm clear. Science is the most difficult, pitiless, hardest, yet very rewarding and very interesting endeavor that mankind has found, humanity has found in the pursuit of finding truth. So, dear friends, even though the original text hanging on the wall is often neglected by many, I never neglected that, and I recorded that in my heart. I have been a PhD scholar in IIT Madras from 2002 to 2008. It's a very long story from 2002 to 2010. I am blessed to be associated with Professor B Viswanathan sir, indeed a great teacher, and I learned much, as including this. Science is the most pitiless, hardest, difficult, yet very interesting and very rewarding endeavor that humanity has found in the pursuit of search for truth. So, what are we doing? We are trying to seek the truth. We are trying to find the truth. In the olden days, the education system is different, whether it is the Anglican Church or the English Church, in the pursuit of their search for truth, means the Jesus Christ. There are only two ways of searching truth. One is reading from the original text, the Holy Bible, and second is the life of the preacher himself. Is the life of the preacher a representation of the life of Jesus as it is written in the Bible? Only these are the two ways the preacher is allowed to preach. The fathers are allowed to preach. None other than these two methods the preachers are allowed to preach. So as much as possible, I'll try to follow the original text. If I deviate, forgive me, because I have much to say and add as interpretation to the original text. Because I was talking to you about the Pilgrim's Progress, and the whole world has been astonished to look at the work of John Bunyan in the book Pilgrim's Progress. How can such a layman write such a literary masterpiece? Not only the world, not only the common layman, even the professor of linguistics, Professor C.S. Lewis from Magdalen College, Oxford University, was astonished to see the work of John Bunyan, that is Pilgrim's Progress. And Professor C.S. Lewis writes in his book, probably in one of his books, he writes, how could such a masterpiece originate from such a layman? In one of his literary works, Professor C.S. Lewis refers to the work of the layman, that is Pilgrim's Progress author. That is the author of Pilgrim's Progress, that is John Bunyan. I have much to say. Moving forward, dear friends, so what we are getting from XPS, that is X-ray photoelectron spectroscopy, is the binding energy of a particular electron, how strongly it is held, it is bound to the core level of the atom. And from that binding energy, and this, of course, this binding energy is characteristic, as the fingerprint that we have is very typical of each of the elements that each of the people that we see all around, as the fingerprint is very characteristic, very typical. Likewise, the binding energy of the electron is characteristic of the element, whether it is a nickel, whether it is oxygen in nickel oxide, if you say polyoxymetalates, in polyoxymetalates, for example, let us take the Kegin type polyoxymetalate, that is silicotungstic acid. Silicotungstic acid means H4Si W12O40. H4Si W12O40. Phosphosilicotungistic acid. Likewise, if we talk of phosphotungistic acid, H3P W12O40. These are metal oxygen clusters, and Japanese scientists like Makoto Misano, Toshio Kuhara have contributed much to unravel the mysteries surrounding the structure, composition, their acidic properties, Bronsted acidity, pseudo-liquid phase behavior, and the various kinds of catalytic reactions that these solid acids can bring about. And there are many things like that. Moving forward, today, as I promised, dear friends, I'll try to move as much forward as possible related to LEED, low energy electron diffraction. Of course, electron diffraction is very important, and these days, every paper we see transmission electron microscopic image in combination with something called electron diffraction. Of course, it's not LEED, it is selected area electron diffraction, SAED. Of course, the governing principles or the kind of interpretations that deduce matters, and there is some coherence and analogy that we can always carry from each of these techniques. moving forward, today we are going to learn about the surface analytical technique called LEED, low energy electron diffraction. There are three important aspects of the study of surface. As I told you, surface is different from interface. Again, surface is not a synonym to interface. Surface and interface are different terms. Interface is the region of union of two different surfaces. Two different surfaces unite, and the narrow region of the union of two different surfaces is called interface. So when we talk of surface, we are talking about only a single material. When we talk of interface, we are talking about two different materials coming and forming a union. Like I'm a bachelor per se. I'm talking about a bachelor when I talk of surface. When I talk of interface, I'm talking of a wife and husband together. When two different people unite together in the holy matrimony, wife and husband form a beautiful union. And such a region of union is called interface. Interface cannot be from a bachelor. A bachelor cannot be forming an interface. A bachelor is a bachelor. It cannot form interface. Interface is for a single bachelor person. A single solid surface contains a surface. A single solid material has a surface, for example, nickel oxide. But when we talk of, composite materials or something like that, there we talk of interface. For example, carbon fiber reinforced composites. When we think of carbon fiber and a polymer matrix, when a carbon fiber is reinforced with resin matrix, a narrow region of interface will be formed where both the properties of carbon fibers, both the surface properties of carbon fibers and the surface properties of resin matrix are intermixed, and a hybrid behavior is expected, because when wife and husband are joined together in holy matrimony, the offspring will have altogether the characters of both the father and the mother. This is what is called interface. Interface will have the properties of both the surfaces from two different materials. For example, the surface of carbon fibers and the surface of composite resin matrix. These two two different surfaces, namely the carbon fiber surface and the resin surface, will form an interface. So interface is different from surface. Going forward, uh, there are three important aspects of the study of surface. These are geometric structure of the surface, chemical composition of the surface, and study of molecules adsorbed on the surface. LEED provides a vital clue on how the surface is modulated, how the surface structure is transformed when some special materials are adsorbed. For example, oxygen is adsorbed on a nickel surface. How the surface pattern of LED looks like. Study of the molecules adsorbed on the surface. We have already seen the importance of exposed planes of a metal in connection with the Balandin's multiplet theory, and in case of adsorption on clean metal single crystal surfaces. The three-dimensional crystal structure of the solid is generally studied by X-ray diffraction. I already told this. X-ray has high penetration power, and the structural information obtained from X-ray diffraction gives the bulk structure. Low energy electrons with the energy in the range of 50 to 100 electron volts, those of X-ray. Low energy electrons with energy of 50 to 100 electron volts have a de Broglie wavelength of the order of an angstrom, that is same as those of X-ray used in diffraction study. Hence, electron diffraction can be a tool for studying the crystal structure. Like X-ray diffraction, we can also study the crystal structure